Hi, Belen.
Hello.
Hey,
How are you?
I'm good. I'm still sleepy. I didn't
Are
get
you
enough
are
sleep
you
yet.
oh, are you in Semarang or still in the yeah.
No, no. Yeah, I already back to Semarang.
Ah, cool, cool, cool.
Mm-hmm. Yeah. Wait, let me. Also, the plan for today, it's like to prepare the project, right?
Yeah, yeah, I can show you there if you want to.
Okay,
But
can I see?
the idea is to talk mostly like making a plan to survey microplastics
Mm,
and try to make some activities to show them how to do it and how to make some decisions, and then we move to making like a real plan in Semarang. But at the end, I mean, I choose one side, but this could
mm-hmm,
be like decided later. Also, we can move it to another place if needed. And regarding the last, I mean, the project, the final project, how they introduce the data, how to present
mm-hmm.
the data, how to make the report.
So,
And but I,
um,
I, I will tell them that the date they will do this file survey will be decided with you after discussion
okay.
in the lecture.
Yeah,
So
that's what I want to
we can
ask
still
when.
talking about it.
Okay,
Yeah.
cool then. Okay then.
Good.
Well, let me remind everybody. Ini kormatnya siapa ya? Koordinator mata kuliahnya. Halo?
Selamat malam Ibu. Em, Kebetulan kormatnya Lamoza Ibu teman saya.
Oh, oke. Belum masuk ya, Lamosa? Mungkin
Harusnya
salah
belum
satu
Ibu.
dari kalian bisa minta tolong temennya untuk segera join. Soalnya apa? Malam ini kita akan bikin grup untuk tugas akhir, ya. Minta tolong deh
Oke,
salah satu dari kalian. Thank you.
baik Ibu, saya izin bantu untuk announce ke teman-teman.
Belen, I'm so sorry. Can we wait like another 10 minute maybe? Sorry, 5 minutes.
Yeah,
And then if 7:15 and then we can start.
okay,
Okay, I'm so
perfect.
sorry.
No worries.
Okay, Belen, I think we can start.
Okay, perfect. I will start then. Thank you very much. So we have until 9 p.m., right?
No, we have until 8. Sorry, now I forgot I think it's until 8:30.
Okay.
Uh-huh.
Okay. Okay. Let me check something. Okay. So I will start. Hello everyone. Welcome today. Good evening. This is lecture number 7 for the students of environmental pollution, but today we also have the people from the University Global Classroom program. So today we are going to talk about like how you become a real researcher from the things that you were learning from the last lectures to put this in practice to do a real monitoring in Semarang. Wait. So this lecture is research design from question to field. We also, as I say before, this is from environmental pollution lecture, but also from the University Global Classroom. So welcome everybody. Everyone, my regular students already know me, but any new visitors today, this is a brief introduction. My name is Maria Belen Alfonso. I'm an associate professor from the Center for Ocean Plastic Studies from Kyushu University in Japan. I study, my research work is mostly on plastic pollution in marine and freshwater environments, mostly microplastics. And I also have some international work with the Ministry of Environment Japan, GPML UNEP, IMDOS, and MAPA, which is a leading national microplastic monitoring initiative I have in my country, in Argentina, with other 50 experts across the country. So today plan, by the end of this lecture, you will be able to do 3 things. First, to explain why microplastics on riverbanks are a valid and important thing to monitor. Second, list the criteria for choosing a good study site. And third, and most importantly, design a sampling protocol that actually you can execute. This is the same skills that researchers have, NGOs and government agencies use every day for microplastic monitoring. So after today's lecture, you will be able to do it yourself. So tonight we use 2 tools, mostly here in the Zoom to interact with each other. First, we are going to use the chat. When I ask a question, you can type an answer, mostly short answers. Keep it simple, 1 line is enough. Please don't hesitate to interact because there is no wrong answers. This is just like trying to learn all together, okay? And the second one is some reactions that you can use for example, for choosing an option when I ask a question. So let's start. Why this matters? Before we design anything, we need to know why we are designing a monitoring, right? Why microplastics, or why to study rivers, or why we are going to follow determined guidelines, international guidelines. So let's start from here. So microplastics are any piece of plastic larger than 2.5 centimeters. This is the size of a coin or even larger, but minimum the size of a coin. So you can see it, you can pick it up, you can identify what it was, maybe a bottle, plastic bag, a food wrapper, maybe a fragment of a plastic bottle. This is what makes microplastics special because you don't need to use a microscope, you don't need to use a laboratory, you only need your eyes, a ruler, and a clear method. So compared to microplastic studies, which is my main research topic, and microplastics, as you remember, is particles, plastic particles with a size smaller than 5 millimeters. So to study microplastic, you need more difficult equipment, laboratory conditions to avoid contamination of samples, microscopes, instruments to measure the plastic polymers like FTIR microscopes. But for microplastic, it's very different. Anyone with training can make a good monitoring for microplastics. So I think this is a very good chance to understand more about the plastic pollution in Semarang. So here's an important point. Most of the plastic in the ocean, by means of weight, is macroplastics. But most of the particles, by number count, is microplastics. Both are important, but they will tell very different stories. If you want to know how much plastic is there in the environment, an easy way to know that is to measure macroplastics and count the mass volumes, because you will understand how much mass volume of microplastic is in the environment. But if you ask how, for example, widespread in the environment is the plastic, measuring microplastics by counting microplastic items, you will have a better understanding of how widespread is the plastic in the environment. We can find microplastics in the water, in the soil, in the organisms. I'm talking about microplastics, right? In the rainwater, as we saw in the last lecture. So both are valid signs, both are important, but they answer very different questions. So in today's lecture, we are going to focus more on macroplastics, on the mass of plastic, the visible part of plastic pollution in the environment. So this is the practical reason microplastics are powerful. To study them, you need a measuring tape, as I said, a notebook, gloves to protect your hands, and a good method. No laboratory, no expensive instrument, no long sample processing times. So that means anyone can do it, okay? NGOs, government inspectors can collect comparable data. This is why citizen science programs around the world focus mostly on macroplastics. For example, here in Indonesia, I think you might heard about the Sungai Watch, and maybe also about Ocean Conservancy, which is a global initiative, or maybe other international initiatives like NOAA from the US, or AOMI from MOEJ, or MAPA, which is my project in Argentina. All of them use the same idea: count the macroplastic that you can see with your eyes. So why we want to focus for this lecture in macroplastics in rivers? In 2021, a researcher team that was led by Lawrence Major published a very important paper. They make a mathematical model to understand where the ocean, where the plastics that they found in the ocean was coming from. The results were that most plastic that enters the ocean comes through rivers. But not all rivers act in the same way. About only 1,000 of rivers around the world, they carry around 80% of all the river influx of plastics to the ocean. This was a big change, a big shift in how we think about the problem, because the ocean does not produce much of the plastic besides the ones coming from fisheries or boats or transportation. The land produces most of the plastics and it flows to the ocean through the rivers. So if you want to stop the ocean to make full of plastic, you need to stop the plastic before in the rivers. So that is very important. That is why it's very important to understand how the pollution in the rivers is behaving. Sadly, Indonesia is listed among the top countries of this river in plastic flows. So this plastic that I mentioned in this paper, most of it comes from Southeast Asia, including Indonesia. And one thing that is very important for you to understand that this is not because Indonesia produces more plastic per person compared to other countries around the world. So why is it happening that Indonesia is contributing a lot of plastic through the rivers? So this is very clear to understand with a clear example. For example, we have two rivers in the study. One is the Ciliwung River in Indonesia, and the other one is the Rhine River from Western Europe. In the case of the Ciliwung River here in Indonesia, on the island of Java, if we compare to the Rhine basin in Europe, this basin is 280 times larger than the river in Indonesia. And the Rhine generates almost twice as much plastic waste. If we compare the waste that is generated in the watershed from Europe, is 34,440 tons per year. But in Indonesia is almost half of it, like 19,000 tons of plastic per year. So this is a very big difference in the amount of plastic produced. In Indonesia, is very much less. But you will expect that the Rhine River to send more plastic to the ocean, right? But actually it happens the opposite. And why is that? This is because the Ciliwung send about 205 tons per year to the ocean compared to the Rhine watershed that sends only 5 tons per year. This is a very big difference. The case of the Ciliwung emits roughly 40 times more plastic to the ocean than compared to this European river. And how that is possible? This is because of 3 reasons. But everything is related to the geography and the climate of Indonesia. In the Ciliwung Basin, waste is generated only 1 kilometer from the river on average. This is an average value. In the case of the European river, 5 kilometers. This is 5 times farther. Also, the Ciliwung River carries waste 29 kilometers to the ocean, when the Rhine River in Europe carries it more than 1,000 kilometers. This is very much far from the ocean. And an important thing is also that the rainfall in the Ciliwung River basin is 2.4 times higher than in the European river. That means that we have more rain. That means more plastic is mobilized from the land to the ocean. So the result is that the probability of a piece of plastic waste in the environment to reach the ocean in Indonesia is 15 times higher, 15%, 15%, when in the European river is only 0.04% of chance of a plastic waste to go from land to the ocean. And that is why the river in Indonesia is providing more plastic waste pollution compared to European rivers that actually produce the watershed, the area around this river. They are using a lot of more plastic per person. So that is why monitoring rivers like the one here in Semarang is not just a local exercise for research. We are contributing to this global data story to understand how it's going on, what is going on, how it's going on. So we have many international guidelines existing for plastic monitoring. How do we monitor in a way that is comparable across countries is using these international organizations that have published many guidelines for plastic monitoring. One example the guidelines from UNEP or IOC. These are UN agencies that work in marine litter monitoring. Also, one example could be NOAA from United States that also has the Marine Debris Monitoring and Assessment Project with very detailed shoreline survey protocols, but mostly for marine environments. We also have the OSPAR in Europe and GESAMP, which is also a UN scientific advisory group. So tonight we are going to use the protocols from NOAA adapted for freshwater environments, for rivers. So why does this matter? Using standardized methods. Imagine that we have two studies. One, but both report plastic pollution in, for example, in a beach. The study I counted everything they could see in 10-meter, for example, and the study B used a different size cutoff of particles to count and different transect length, maybe 50 meters, 20 meters. Can we compare them? No. The numbers are not comparable in these studies because even if both are very honest with their protocols, they are not comparable, so they cannot be combined. That is why standardized methods solve this problem. If two studies follow the same protocol, the numbers will be comparable. You can build data sets across years, across different sites, across different countries. So this is how science could be scaled globally. Not by everyone doing their own thing, but by everyone agreeing on a method first. That is what we are going to do today lecture. We are not going to invent a new method to count macroplastic in the river coast, but to adapt a method from marine system to be used in river systems. So before we design a study, we need to think about a little bit what we are studying, right? Where does this plastic on the riverbank actually came from? So plastics on the riverbanks does not come from one place only. It comes from many at the same time. Let me give you the main categories as a framework. We have domestic sources like household waste, food packaging, bags from the homes near the river area. Also, we have commercial sources like shops, markets, food vendors in the street. Also, we have industrial sources, which means factories, workshop, any small business, or maybe drainage and runoff plastic that are carried by the rain from the streets in the river to the river. We also have recreational sources like, for example, people fishing in the area that are using plastic items, or maybe people doing picnics, or maybe a concert or an event near the riverbank. And of course, tourism, many visitors, vendors near the touristic areas, many of them use plastic items. Or finally, illegal dumping when plastics are deposited directly into or near the riverbanks. So in the case of most rivers, they have many of these sources. Often they overlap. That is one reason monitoring is very difficult because you usually can't tell where a single bottle came from. But you can see the patterns. If a site has many food wrappers and many small bags, it tells one story. If it has like industrial film and packaging, it tells another story. So let's make a short activity in the chat. This is our first activity tonight. I want you to think about it for a moment, and then type a result in the chat. I want you to think and type one possible source of macroplastics in urban rivers here in Cimarron. You need to type just one idea, one source per person, okay? Don't think it too hard. Type the first thing that comes to your mind that could be a source of macroplastics in a river here in Cimarron. Okay, maybe let's take 1 minute to think and type a few answers on the chat. Remember the examples that we mentioned a few minutes ago: domestic sources, commercial, industrial, recreational, tourism, illegal dumping. Based on that, maybe think a few examples of plastic waste, of plastic pollution that can reach the rivers in Semarang. Street vendors, good. What kind of plastic items can come from street vendors? Maybe plastic bags, right? Who else? Think about when you go to the river or an area near to the river here in Semarang, what kind of plastic that you observe in the area maybe? Maybe plastic bag, plastic glass, plastic straws. Very good. These are very clear examples, very common to find. We use it a lot every day, right? Anyone else? I want to see answers from the environmental pollution lecture. We have many students today. Think about the items that you use every day or that you see every day.
Silakan teman-teman jawabannya.
Household garbage, such detergent sachets, bottles, or toothpaste tubes. Yeah, very good. This is very good examples of plastic pollution from household. Yes. I read about that in Indonesia it's very common to use many sachets, plastic sachets, right? Not just for detergent, but also other items. Okay, maybe I will continue and you can keep typing in the chat any ideas that you have of plastic items. Convenience stores, plastic bottles. That's a very good example, Abdul. Thank you very much. Okay, let's continue. So, if we look at the list of the things that you type in the chat, we have many different sources. Some are very specific, others might be more general, but this is the reality. Plastic on a riverbank can come from many places, like household, convenience stores, food vendors. You almost never have one source. And that is exactly why monitoring matters. If we want to manage the plastic problem, we need to know which sources contribute most to a particular site or environment. We need to know what kind of plastic accumulate there. Maybe in a particular area, we will find typical particular plastic waste. And the only way to know that is to measure. That brings us to the next question, which is, where do we measure? But before that, I want you to see the three pictures. From the pictures, you can see in the first one, there is one man stirring a lot of plastic pollution. But if you see what kind of items we can see in the picture, you will see a lot of items coming from fisheries, like plastic buoys, styrofoam containers. This is very typical fingerprint of plastic pollution coming from fisheries. Maybe fishing nets, all this plastic comes from fisheries. But in the other picture, you see a lot of plastic bottles, PET bottles. So in this case, we can see clearly that maybe convenience store plastic bottles or people throwing away or discarding in a wrong way the plastic bottles made all this plastic pollution coming to this beach. Or in the last picture, you can see other kind of plastic items. Looks like a lot of plastic bags, right? So in this case, I will say that probably this plastic pollution is coming from household garbage. That is the way we can try to interpret the sources from what we found in the environment. So how to choose a study site? Before any measurement, before any protocol, we need to choose a site. This is one of the most important decisions in a study, and often is one of the most underestimated, I would say. So why does the site choice matter so much? There's two main reasons. The first one is the representativeness. The site is what your data will represent. If you pick a very strange or weird or unusual place, your data will tell you about that strange situation, not about the river condition in general. And the second thing to consider is the feasibility. This is very important. If the site that we choose for a monitoring is impossible to get there, is very dangerous, we cannot repeat the monitoring over time because it's very hard to get there, your study will not happen probably, or will not continue through years to time. So it's very important to consider it, to choose a place which is representative of the river watershed and also which is easy to get there, easy to measure. So a balance between these two, it will make a site be very meaningful and possible to continue the monitoring. So here are 6 criteria you should think about for every study site. You can take notes if you want, because this is very important for your next plan. One is safety. Safety is very important. This means that we are going to choose an area where there is no traffic risk, no flood risk, no maybe aggressive animals around. There is a place where we can walk very easily with no problem. Also the access, we prefer to choose a place which is public, that we don't need a special permission to get there, or that is not so far from the accessible road. The other thing to consider is the representativeness, as we mentioned before. This is very typical area of the river, or is a very particular special place. The repeatability, can you find the exact same spot again and again, every month, every year? This is very important. You need to choose a place that you can get there every year, every time that you want to repeat the monitoring. And another thing is the criteria of the background. Is there ongoing dumping nearby? For example, there is an open waste place nearby this place, or maybe was an area where people is doing cleanups very frequently, because that will change what kind of data we can get from that place. If it's a place near a dumping site or near a cleanup area, this is not so representative, right? And also the logistics, this is very important, because how long does it take to get to this place? For example, do we need a bathroom because we need like to work there like many hours? There is some shade that we can protect from the sun during the day we are working there. All these 6 criteria are very important. If you ignore them, your study will have probably some problems later. So in real research planning, scientists often visit a site maybe once just to check all these criteria, and this is called a pilot study. When you go there and check the place to see if the conditions are good. So what will look like a good site versus a bad site? Let's see an hypothetical example. On the left, we have like a bad site. For example, it's very close to a road. Maybe we have no shade, sorry. No, the steep of the terrain is very slope, so it's very hard to monitor in there because probably we will fall in the water. um, Maybe there was a recent cleanup and we will not find many plastic pollution coming from the area. But on the right, maybe you have a picture of a good example, which is a safe place to walk around, looks like a public access area. The ground is flat for measuring. We have no recent cleanup signals or information from this area. So we probably will find a mix of plastic types very visible. So this is the same river, but different stories for the data we can obtain from one side or another side. So both sides will tell you something, but they will tell you very different things. The bad side will tell you about a specific disturbance or situation, and the good side will tell you about general riverbank accumulation in the area. So in the case of Semarang, we have many candidates to monitoring microplastics in rivers or water canals. Semarang is a city with many rivers and canals. Some flow from the hills into the city. Some are flood canals built to manage the rainwater. Some of them are very old, some are very new. So each one is a possible study site for our purpose. Each one has very different sources, many different type of access or different type of plastic profiles that we can find. So you as students living in this city, you know the places much better than me. Places where you might see plastic accumulated, places near your place, your home, near your campus, or near a market, for example. All that knowledge from local people is very important data that you can use as a background when you choose the place when you're going to do our research. So let's do a very short activity now again. I want you to write in the chat. This is our second activity. I want you to imagine you're designing this study. I want you to think about where in Semarang would you go to measure microplastics in a river. I want you to type in the chat the name of a river or an area or a canal from Semarang. Maybe that is near to a bridge or a market or maybe a public park or a neighborhood, particular neighborhood. So I want you to write down one site per person, but don't worry about being wrong because this is kind of brainstorming to select maybe a potential place that we can choose in Semarang for monitoring microplastics. So maybe let's try to see a few ideas. You are the local here, you know better than me which place will be a good idea to go and measure microplastics. the idea is for you to mention, for example, good idea to do a microplastic survey will be this part of the river because it's close to this park. And mention maybe a good reason because it's very easy to access or is a a common use area during the weekends, something like that. Do you have any ideas? Anyone from the audience?
Yeah, I'm sure that you guys have some place in your mind. You can start from the place nearby the campus, for example, or nearby your house. Or then you just go around Semarang in the bigger area. Because this is also part of the project at the end, so we will decide which area is the best for you guys to sample the data later on. Silakan teman-teman. Ini pada kemana ini? Kok tidak ada yang menjawab? Silakan di-type di chat.
We have one answer. Good. So maybe do microplastic survey around the Marina Beach because it is very near to the residential area. Yeah, that's a good idea. Thank you very much, Marco. Kota Lama Semarang because it's a crowded tourist area with many cafes and visitors. Yeah, that's a good idea. So if we have many cafes, visitors, probably we will find plastic cups from coffees, from iced coffees, or plastic bottles from water, maybe. Food packaging from street vendors. Another example, Simpang Lima, Semarang, because it has heavy human activity, street food vendors, and traffic. Yeah, if we have a lot of traffic, could be maybe a problem to get there, or you mean like traffic as a source of plastic pollution? I guess as a source, right? Maybe traffic driver just throw through the window of the car some plastics. In the river, Banjir, Canal Timur, landmark Pasar Johar, Semarang. The reason? Crowded area, easy to observe pollution and human activities. Very good. These are very good examples that you guys just put in the chat. Many of them looks like very accessible, like representative from the area and easy to repeat through time that we can go there every time that we want to, right? Okay, maybe let's try to continue. If you want to put other examples in the chat through the class, keep doing so because these are very good ideas for the LAX project that we have that as Dita mentioned. Okay. So for our course, I designed this lecture for today I'm using as an example the Banchier Canal Timur that actually Gabriel just mentioned as an example, so it's very good. This is an example that we are going to use through the final part of the class, but we can still keep discussing about where you guys would like to go to do this activity based on the accessible place or you're interested, okay? So the Banchir Canal, Timur, why I choose this place? Because it covers most of the 6 criteria that I mentioned before. It's safe, we can walk around, it's away from the road, it's very easy to access because it's a public area, we don't need a permit for this academic activity. It's very representative because drains a large part of the central Semarang city to the sea. Also, we can go there and repeat this monitoring because it's easy place to find. The landmarks are very visible. And also the background, we know that this receives a lot of probably urban runoff from the city. And maybe we can get some information if there was a cleanup or not in this area, which is very important as a background information. And regarding the logistics, is a reasonable distance from the campus area, so I guess most of you can get there very easily to do this activity. So today we are going to design a protocol using this site as an example. But the thinking that you just did, like choosing among different sites, considering the situations, that is the skill you will use, you will use again every time you want to make a study, a monitoring study. Okay, so the site is already selected. Now we need to design the actual survey, okay, the protocol that we are going to use in this activity. So in this consideration, designing the protocol, there is 6 decisions that we need to make. For 4 decisions, you are going to vote, and we are going to discuss. But for 2 of them, I will show you based on the methods and the protocols from the guidelines I mentioned before from NOAA from the US. So let's go. Decision number 1 is what size of plastic we are going to go there and try to count. This sounds very simple, but actually is not, and it's very important. If you say, for example, anything over 1 centimeter, you will count many items, some tiny fragments of plastic or bottle caps, cigarette filters, and your survey will take some time. But if you only say, for example, I want to only measure the plastic that are bigger than 10 centimeters, you will, for example, miss some items like a plastic cup, which is with a size very small compared to 10 centimeter. So you need what we call a cutoff, a lower limit, a threshold for the size of the particles of the items that we are going to measure and collect from the survey. Below that size, we are going to ignore. But above that size that we are going to decide, we are going to count it as a macroplastic. So we have 4 options here. The option A is using items bigger than 1 centimeter. These include very small fragments, so you will need to pay a lot close attention to the floor, very detailed. The option B is items bigger than 2.5 centimeters, which is the international standard for the definition of macroplastics. Macroplastic is any plastic item bigger than 2.5 centimeters. The option C, if we are going to measure everything bigger than 5 centimeters, which is maybe faster and very more easy to measure. And the option D is we have no minimum. We will just count anything that we find in this river canal. So now I want you to vote using the reactions from the Zoom. I will need a little bit help because I cannot see your reactions. So maybe Dita can help me to check which is the most vote of the options. So we have for option A a thumb up, option B a heart, option C a raise hand, and option D a party celebration. So maybe let's take a few seconds to vote.
There's two, I think it's 2%. There's 2D. Everyone else, please vote. 3, 4.
I opened the Zoom in my chat so I can see also the reactions. I'm seeing a lot of parties.
Oh, you can see in the oh, wow. Okay. Looks like everybody choose D.
This looks like a party.
Yeah, this looks like a party.
Everyone is saying so. Just go there and measure whatever we found. Or everyone is very enthusiastic about party.
Yeah.
I'm not sure. So let's see. No, the right option was
The
the
right
heart.
option.
We use the international standard definition of microplastics. And why? Why I choose this option? Don't cry. Because this means that if we collect the items that are for definition microplastics, that means that our data we can compare with other studies, not only from Semarang, but also from other countries or other cities. So that will make will be a very balanced monitoring because it's small enough to catch meaningful items, but not so large to miss some plastic items. And it's very widely used definition of microplastics, including UN and many national programs, so you will be able to compare your data. So for our study, we are going to choose to monitor items bigger than 2.5 centimeters. Okay, let's continue. This is decision number 2. Where on the riverbank are we going to sample? So a riverbank is not just one place. We have different zones, different areas. For example, we have the top of the bank far from the water, which maybe items are deposited here, usually coming from people or from the city. And maybe we have also the slope area of the riverbank, because this is between the top and close to the other limit is close to the water, right? So in the slope, maybe there will be some plastic items that wash away from the river or maybe fallen from the city. And then we have also close to the water line, next to the water, right? Items here that we find, plastic items here, maybe coming from a recent fresh from the water, from the river, right? So we have 4 options here, and I want you to choose one for your survey in the river in Semarang. So we have option A, top of the bank only. Option B, in waterline only, which is near to the water. Option C, only in the slope between the water and between the city, let's say. And option D is random spots, no fixed zone. So option A, top only, Option B, only near to the water. Option C, all the full slope from the top to the water. And option D, some random spots, but nothing fixed. So now let's choose again. For the top only, you're going to put like a thumb up. For waterline only, a heart. For the full slope from the top to the water, a raising hand. And random spot, a party. What do you choose? Marco says the top. Anyone else? Raising hands, I think is C. Raising hands, C. Full slope, full slope. Okay, many for option C. Camila also for option C. Okay, most of you option C. Marco is changing his mind. Option C, option C. Okay, let's see. Yes, option C, full slope, top of the bank to the waterline. A heart, okay. Why we choose the option C to cover all from the top to the waterline? If we sample only the top, we will miss what is happening from the river deposits. But if we sample only next to the waterline, we will miss what happened, for example, from the trash coming from the city or that people left behind next to the river. So if we cover all the slope from top to bottom, it will capture the full story, right? We will have all the information of the plastic input in this river. The human input, or maybe some plastic coming from the river itself, from the watershed after the runoff, all the story together. In the case of option D, the random spot, it sounds very scientific for a survey, but it makes very hard to compare your data because we will have different teams sampling different zones and maybe results in very biased data or difficult to compare. So a fixed zone is better than a random one because it can be repeated and it can be defended. So we are going to use a method based on NOAA, which is from the US, and I modified it for my project in rivers and lakes from Argentina because most of the guidelines are made for in marine environments. Plastic guidelines for monitoring are made, most of them for marine environments like a beach. But if we are going to do a survey in a river, as you can see in the picture, a river is very different from a beach. In a beach, we can maybe have a very long line of coast that we can survey with no disturbance, no plants, we can walk around with no problems. But in the case of the river, we cannot choose like walk freely across all the river, and we also have the meanders from the river. That is why applying a protocol that is designed for marine environments like a beach maybe will not work in a riverside. So here is the first part of the method. We are going to define a 50-meter transect. This is a line, a straight line along the riverbank. So we have the riverbank, and we are going to survey across 50 meters if possible, if we have no interruptions. If it happens that the river doesn't have 50 meters that we can walk around, we can reduce the length. But this is hypothetical for this situation, okay? So 50 meters will be, for example, long enough to capture the variation of plastic pollution along the riverbank, because the plastic will not be uniformly distributed. We will find the plastic in patches. Maybe an area will have a lot of plastic, another area maybe nothing. The second thing why we choose this length is because it's short enough to be manageable in one fieldwork session. We can do it in one day. If we do 100 meters like the protocols from the NOAA say for the beach, maybe it takes too much time. We cannot finish in one day. And also will be not applicable maybe for the riverside. So we are going to choose this method because of this context, okay? So what's the idea? Within this 50-meter transect, we are not going to sample everything around there, but because it will also take too much time. We are going to sample 6 subsites. These subsites are 5 meters wide across the bank and 10 meters long along the bank. It's like a small area across this 50 meters long transect. So each one of this area, it covers around 50 square meters, if possible. We can adjust this according to the area that we choose to go. So each one of these 6 subsites means that we are going to survey in total 300 square meters. That is a lot, and it's very relevant and important information that we can retrieve from this area. But we are not going to place these subsites evenly, uniformly. They're going to be placed in random positions. This is to avoid the bias, because if we see that some area has a lot of plastic and maybe the other area in the 50 meters transect has not much plastic, we might tend to choose to measure in the place that there is a lot of plastic. So if we decide the position of these subsites randomly, we reduce the bias of just measuring where is a lot of plastic. So why this design will work? Because the 6 subsites means that we have 6 independent measurements. This is what we call replications. With 6 numbers, 6 measurements, we can calculate a mean abundance of plastics per square meter. We can calculate also the variation, for example, the minimum and the maximum value that we found in this survey. We can say not just like we found this number of items, but we can say more about it. How is the variability? How is the average value? That is what makes a measurement more scientific, more relevant. One number alone is just a number and it's like just taking a picture. But 6 numbers tell you a story, tell you more about the information. Also, if we choose 6 places, 6 subsites, it's very easy to manage because you are like 30 students. So we can plan maybe making groups of 5 people each, and each group will go and survey one of these sites. And the design will be comparable because everyone we are going to use the same protocol, we will have the same information, and the data will be comparable among all of us. So this is how it will look like applied to the Banchier Canal. We will have the Canal River. We will have a 50 meters transect, and across there we are going to choose 5 random places and put these subsites that are like 50 square meters in random positions. So each group, we are going to survey every microplastic item larger than 2.5 centimeters that you find in this area. The other question that we need to understand now we have the where are going to measure. The second question is what categories are we going to record in the place, because we have many types of plastics, and it's very good to differentiate different categories so we can understand the sources of these plastics. So we are going to design kind of a data sheet, and we are going to place different categories, and every item that we collect, we are going to measure and collect it according to the category. If we don't define the categories in advance, every group will categorize differently according to what they think the item is. But if we have very fixed categories, everyone are going to record the data in the same way. So here we are going to make another decision. Which are the categories that we are going to use? The option A is that we are going to use standard categories. For example, everyone are going to measure bottles, bag, pumps, fragments, cigarette butts, etc. The option B is that we can use like free text. Everyone will describe the item that they think with their own words, and then we are going to compare the data. The option C is we are going just to record the brands. For example, then the brand name of a plastic bottle, the brand name of a plastic bag, and so on. And the option D is that we might be only recording the weight of each item, and we are going to count and just measure the weight. So let's vote with the reaction. For option A, thumb up. For option B, a heart. Option C, the raised hand. And option D, the part.2. So most of you are choosing the standard categories. Very good. You really like the reactions. Okay, looks like we have a winner. Option A, standard categories. Very good. That's the right option. So our answer is the 8. We are going to use 12 standard categories. Why? Because if we use like free text, it sounds very flexible, but the data will be impossible to combine and compare across teams, so will not be useful. In the case of option C, if we only take notes of the brands that we find on the plastic items, is very interesting information. Actually, if you also want to take notes of the brands, is a very common practice. But miss most of the plastic because some plastic will not have a brand. Option D, measuring only the weight. This is also an option that we can also do, but because it's quite simple, but we will lose a lot of information about what kind of plastic are there, because only knowing the weight, we have no information. If it was a bottle, it was a plastic cup, we lose all that information. So option A, using categories, is the standard used by many NGOs or NOAA or Sungai Watch, for example, here in Indonesia, when they are doing the riverine surveys programs. So in our case, we are going to use the categories that you can see in the screen. They are very common. We are going to use bottles, bags, sachets, because are very commonly used here in Indonesia, particularly. Food wrappers and cups. This is like food packaging. Cigarette butts, fishing gear. Maybe we are not going to find fishing gear, but possible. Textiles means any clothes or textiles. Film fragments, some hard fragments, and foam fragments. In these three categories, sometimes the plastics are already fragmented. And in that case, we need to put it in a category, and we are going to choose these three. If it's a foam, if it's a hard plastic, or film. Maybe a fragment of a plastic bag could be a film fragment. And then we have sanitary items like diapers or that kind of things that might show up in this kind of river service, but in this case we need to be very careful not to touch it or anything like that. And final category, others. Anything that not falls in any of these categories will be categorized as others. So decision number 4 is the clear rules for what we found. This is the last decision and the most subtle. In the field, you will see items that are very ambiguous, maybe a piece of plastic that is half buried in the mud, or maybe a plastic bag that is torn into many fragments, many pieces, already fragmented, or an item right at the edge of your subsite. Maybe it's not completely inside of the area we designate to measure. What we are going to do there? So if we decide in the field, every group will decide differently, and that will bring a lot of bias to the survey. So the solution is to write the rules before we go to the field. When to say yes and when to say no to a plastic. So here are the rules that we are going to use. We are going to use a minimum size target or any plastic bigger than 2.5 centimeters in the longest dimension. Also, in the case of an item that is a little bit buried in the mud, if more than half of the item is outside, we are going to count it. But if it's too buried, we are not going to count it. In the case of fragmented items, for example, if a single bag has already torn into many pieces, we can recognize it's part of the same bag, we are going to count as one item. But if we have fragments, individual fragments that we cannot recognize this is part of a plastic bottle or a bag or anything, we are going to categorize as a film fragment or a foam fragment or a hard plastic fragment. In the case of buried items, if visible at the surface, we are going to count it, but if it's fully bare, we cannot see it, we are not going to count it, okay? And in the case of organic items like wood or leaves or food waste, we are not going to count those kind of items. And if you have any doubt, you just cannot decide. Just in case, you will photograph the item and we'll take the notes and we can discuss and decide later. So these are the clear rules that we need to follow. And why these rules are very important, why it matters so much? Because if two groups at the same site with the same training will get different numbers if the rules are not clear, okay? So this is one of the most common reasons why monitoring studies sometimes disagree, not because the river is different, but not because the team was working inappropriately, but because the rules were not very clear from the beginning. So in real science studies, these rules are part of the method of the paper, and they are public, and anyone who wants to repeat the same protocol to measure in a different place, they will do the same and the data will be comparable. So don't worry, before this practice, we are going to prepare a data sheet to collect all the information, a protocol where you can follow up each step, and also all the rules, when to measure, when to not include in the protocol, in the monitoring. So let's put it all together. So we decide the Banjir, Canal Timur, Semarang. East Canal preliminary. We can change this if you want to. If you're interested in doing a survey in a different place, maybe we can discuss it. We can use, we are going to use a transect of 50 meters along the bank. We are going to use subsides of 50 square meters in random positions. We are going to measure the full slope from the top of the bank to the waterline. We are going to include only items bigger than 2.5 centimeter. We are going to use 12 standard categories. We already set the rules for inclusion or exclusion of items. And we are going to count and collect every item and take a photo of each item for analyze the data later. So this is the protocol that you are going to use. And why is this important? Because your data from this survey, this monitoring will be comparable with any protocol that you are going to use in other studies worldwide. This is not just like a common class exercise. The numbers you will collect from the Semarang River will be comparable to other studies. And this is very important. You're going to use the same logic, the same kind of decisions. Maybe other study will be in a different river, but you have the same scientific approach. So your data will be comparable to others. And this is so we continue. Sorry. So after the field work, what happens to the numbers that you're going to obtain? So we are going to obtain the data in data sheets that we are going to fill during the monitoring. We are going to share the table. Each group will enter the data in the same kind of table, and we are going to do an analysis based on this. Using total graphs or comparisons to make a final report with your interpretations and your conclusions based on the data that we collect. So we are going to put all the numbers in a table similar like this with the different categories and the total numbers in each one of the subparcels, subsites that each group is going to monitor. So these are the three simple ways that you can show your data. For example, items per category. We can make a graph for items per subsite. We can make a graph or the categories per subsite. So this way we can visualize the data in an easy way to compare and take conclusions. These are the three basic numbers that you can use to describe your data. One is the total numbers of items that you found in all the subsites or per subsite, and the mean or the average value, which is the total divided the subsites, and the items per square meter, which is for the full area that we measure how many items we can find per square meter. This is the numbers that we can use to compare from other studies to see and have an idea, like this is too much pollution, this is very low pollution. So the 8 questions that you can include in your final report, one could be, how many items did you find in total? Which categories was the most abundant? Maybe plastic bottles, maybe plastic bag. Which was the category with the least abundance? Another question could be, which subsite has the most items? So the distribution of the plastic items was very uniform. All the sites has the same numbers, or maybe an area has more plastic pollution than other. How different were the subsites from each other? What does the most common category tell us about the sources? For example, what kind of plastic item we found very commonly in this area, and what kind of information we can retrieve from that? For example, if we find a lot of cigarette butts, we can say people is coming here to smoke and they always throw the cigarette butts. So maybe a decision that we can make or making this better is to installing some bins to the cigarette butts in this area. Or another question could be, how did our count compare with our prediction from the class? Because maybe we can go there with the question of how much plastic we are expecting to find in this particular area. This is like a hypothesis. What surprised us? What will we do differently from this survey? And what could our method not capture? Maybe our method has some limitations, and then when we practice and we use the method in the monitoring, we will find out a lot of things that, oh, using this method, I was not able to do this or do that. These are the limitations. So very important to also take notes of these limitations that we found once we go to the environment. And this is a file logistics, like how to survive the field survey. It's very important, your safety. So we are going to use closed shoes and protection like gloves and a hat and sunscreen. Take your own water bottles, and never enter to the river water. And we are going to use different equipments like a measuring tape, the data sheets, the pencil, etc. And we are going to divide the groups by roles. This means one people will be in charge of measure the items, maybe other to record in the data sheets, other ones will take pictures of each item. Another one could be the one collecting the items in a plastic bag, and so on. And maybe we can change the roles during the survey so everyone can practice. So one final question could be, what is your prediction for, this is next week, this is a mistake. We are not doing this survey next week, sorry. So this is a prediction of what you're going to expect if we go to the river canal. Are you expecting fewer than 50 items per square meter? Or a heart if you're expecting between 50 and 200 items? Or raise your hand if you expect between 200 and 500 items per square meter, or celebrate if you expect more than 500 items, which is a lot. Let's just make an assumption. What are you expecting from a plastic survey in this area? This is more a game than, but maybe we can prove once we have the data which one was correct. So what are you expecting? Marco says between 50 and 200. There is no wrong answer here. We are just guessing. Camila also, hearts, many hearts. So everyone is around 50 and 200. No one expecting less than 50? Wow, more than 500, Deminis. That would be very, very sad. I hope not. Anyone else? Okay. So why this consideration is important? Because when we go there and count, we will find that our prediction was right, or maybe we were wrong. This is how scientists work. Every time we do a research survey, we have like an initial idea of what to expect, but sometimes we can say, okay, we were right about this hypothesis or we were wrong. That's why we measure, we compare, we do predictions, and we check. So to finalize, these are the 6 takeaways. And what's next? So by the end of this lecture, 6 things to take home. Microplastics are countable. You don't need a lab to make a
Sorry, Belen.
microplastic survey. Yeah.
Belen, I'm so sorry I have to cut. Can I do a quick presence first before it close? Asking the student who is not coming.
Mhm.
I'm so sorry. It will be fast. Teman-teman,
Yeah.
Permata Bekti Asih datang nggak? Nggak ada ya? Oke. Faidatul Maulaya Sifa? Oke, nggak ada. Naisa Diva Aprilia? Oke, nggak ada. Nela Nufaila Zulfa? Oke, nggak ada. Zahra Nurul Kalisa?
Hadir Ibu.
Oke. Eh, Putri Wulandari? Oke. Elka Rospita? Oke. Zawaid Ridlo? Oke. Anastasia Awani? Nggak ada. Oke, thank you guys. Thank you, Belen. You can continue. I'm so sorry.
No, it's just finishing. So the important things to take away from this class is that to measure plastic pollution using microplastics is very easy. You don't need a lab. Anyone can do it following the same protocols. That also rivers are where ocean plastics come from through the land. And that the site choice is part of the method. You need to follow the 6 criteria that we mentioned before. That a protocol is a series of decisions, and each one is very important and defensible and discussable. Standardized methods make data comparable. This is something I mentioned many times through different lectures and very important. And the rules I write in always in advance to protect us from data bias in the field. So for the final assignment, we will design this protocol. You're going to collect the data and you're going to do your own report. So the survey day we discuss this maybe later with Professor Dita, and we are going to discuss also the final place that we are going to do this activity. So thank you, everyone. I want to know if you have any questions. If not, you can always contact us anytime. But if you have any question now, please don't hesitate. You can speak or directly put it in the chat.
Belen, I have a question.
Yeah.
So next week, not next week, this Friday, you will still have
Friday.
one last
Yeah.
class, right? On
Yes.
offline class. What the topic will be? Can you remind me?
Yeah, the topic for the next lecture will be to try to understand how all this data from the monitorings will serve to the government decisions.
Okay.
We're going to cover about those topics.
Okay. So maybe can I get like a 10 to 15 minutes just to prepare everything, like to make sure that the student, all of you guys, understand what the task, what to prepare, because I think next week, because we will meet everybody in the class, so maybe make it clear. So maybe, I don't know, in the first, before the class or maybe after the class, it's just like a 10 to 15 minutes, just make sure that everybody knows what they're doing, and maybe deciding the groups for them. Well, they can decide, but at least
Yeah.
remind them that they have, each of the person in the group also have a task to do. Yeah,
Perfect.
okay, thank you. So teman-teman, not minggu depan, besok Jumat, kelas terakhir di semester ini juga sebenarnya, and then Dr. Belen akan memperlihatkan how the data can be translated, especially for the governments, and then we will have 10 to 15 minutes untuk mempersiapkan sampling, pengambilan data. Jadi nanti di situ juga kita tentukan kapan tanggalnya, the date, and then the place, and also the groups. And then at the end, we'll have some sort, maybe we can do a Zoom when we finish the data and then present it also to Dr. Belen. Jadi itu ya
Yeah.
plannya. Okay then, because I'm just thinking, I also need some a lot of like photos, documentation, not
Yes.
yeah, not only the samples but also the activity. Let's make some small like a poster, so we can put it in front of the lab and seeing how we do the survey and how you guys can what you call it, like discuss the result.
That's
Maybe
perfect.
that's what I'm asking. Yeah. Okay.
Sounds
Any
great.
question, guys? Please, if you have a question, you can just raise it right now.
Yeah. I will share the PDF of this lecture so you can check it during the week before Friday. And also, if I have time, I will try to prepare the protocols and send it to Professor Rita so she can send it to you and you can start checking the protocol steps. So if you have more specific questions, will be nice to discuss by the end or before the next class.
Okay,
So yeah.
cool. Any question, guys, before we close? I think no question for today. So if you still have a question in
Okay.
your mind, make sure that you write it down and we can ask next in the next class, yeah, on Friday.
Ibu,
Oh yeah,
sorry, I have questions.
yeah.
Izin bertanya Ibu, mungkin untuk pembagian kelompok. Jadi, so we already made some groups already, like I think 10 groups. So each groups has around 5 people in it. So do we have to
Mhm.
make a new groups for the samplings, or do we stay in the same groups as before?
Okay. Belen, what is the best things to do? Is it possible to extend the 50 meters or we just make the group into six? Is it six, right, in the design?
Yeah, I mean, yeah, in the design I choose 6 groups of 5 people because you have many tasks to do, so it's better to divide among, but we can manage. I mean, each group doesn't need to be exactly 5 people, could be more or less as you
Yes.
like.
So I think if we made it into six group, how many people per group, Marco? 7?
Yeah, around 7
Around
orang
6?
sih Ibu. Yeah,
Okay.
around.
Yeah, we can also include another
Okay.
subgroup if necessary. We can modify easily. Yeah,
Yeah,
no
so
worries.
because if we make it as a 10 group, so we have to extend the transect line. So do you want to discuss that next week maybe?
Yeah, sure.
Yeah.
Just let
Okay.
me know the total number of students and I will redesign according to that.
Yeah, it's actually 49. There's like
49. Okay,
yeah, we
cool.
have 49. So Marco already have like I think everybody already have 10 groups with 5 on in each group and one group is 4, of course. So let's see
Okay.
next week
Okay.
whether we still use 10 groups and extend the transect line or we just regroup everybody to be 6 group. Okay.
Okay.
I'll take a
Perfect.
note with that. Thank you, Marco. Anything else, guys?
Can I ask my last question?
Yes,
Yeah.
please.
So technically, this is for our final project, so we don't have to do any kind of UAS kan, Ibu?
No,
Atau
yeah. No, 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 no.
okay,
There's
okay.
no yeah, there's no final like the test for the final. Your final is the project.
Oke, terima kasih Ibu.
Okay. Anything else? Okay, okay, Belen, here I think you can
Okay.
close the class.
Okay, thank you very much, guys, for your attention today, and see you next Friday on site.
Okay, great. Thank you so much,
Great.
everyone. Thank you, Belen.
Thank you, everyone. Have a good night.
Okay, you too. Bye-bye, guys. Have a good night.
Thank you, Dr. Belen. Thank you, Budita.
Thank you.
Yuk, sama-sama.